do some sequences and series. So I've chosen these questions for you guys to do. If there's time, then I would also like to do a question that's a little bit more difficult as well. But what's really nice about these questions is it just ensures that we have covered the basics. Although question 3.2.2 is a little bit difficult, and then there's another more sort of difficult question down here as well, but we'll get to that in due course. Okay, so they give us the following number pattern, and it goes -8, -7, 0, and then 13. They want us to write down the next term in the pattern. So how would we work out what the next term in the pattern is going to be? What would we use? Exactly, Diana. Differences. Typing in the chat, just give me 1 second. Okay, so working with our differences. So the first thing that we would do is work out what the first difference is. So we've got -8, -7, 0, and then 13. So if we want to work out the first term of our first difference, we would say -7 minus -8, and that would give us a difference of 1. Then here we would say 0 minus -7, and that would give us a difference of 7. And then here we would say 13 minus 0, and that would give us a difference of 13. What would we do now? What do you think we should do? Okay, so Diana says we're going to take another difference. All right, so we're going to say 7 minus 1 is 6. And then on this side over here, 13 minus 7 is 6. So straight away, the minute we see that, what sort of pattern does this have to be? What sort of pattern does this have to be? Absolutely, you're all correct. Okay, it has to be a quadratic pattern because it's only quadratic patterns where we've got a first difference that's linear and a second difference that is constant. Okay, 100%. Perfect, perfect, perfect. So we know that this has to be a quadratic pattern. And in fact, if we took a sneak peek at the next question, even though we're not supposed to do that, we can see here that they're telling us that Tn is equal to 3n squared minus 8n minus 3. So that's a dead giveaway that it's going to be quadratic. All right, but back to the first thing. How are we now going to work out what the next number in the pattern is going to be? How are we going to work out what needs to be added onto 13 in order to get the fifth term over here, term 5? What would we have to do? Okay, what are we adding 6 to, Diana, to 13? Oh, there we go. All right, so 6 plus 13 needs to be added to 13, quite right. Okay, so we would have 13 plus 6, and that should give us term 5 equal to 32. Okay, so the next term in the pattern is 32. Yeah, 57 would be the next one. Quite right. Perfect. Well done. Okay, so we're going to get 2 marks for that. Now they say to us, show that the nth term of the pattern is whatever. So when we see show that in maths, what are we not allowed to do? What's not okay? What are we not allowed to do? Exactly. We're not allowed to use the information that we've been given. Okay, so we're not allowed to verify by substitution. Okay, verification by substitution is not allowed. So we have to pretend that we do not know that that is the answer. Okay, we have to pretend we don't know. So our first step in question 3.1.2 is to do what then, Matrix? We have to pretend like we do not know that that is the answer. What is the first step when it comes to quadratic patterns? There we go. Okay, That's it. Yes, Diana. Yes, Basihle. Perfect. We have to say that 2a equals 6. So we're going to use those rules. Lovely, Fahim. Quite right. So that means that a is equal to 3. Okay, so now we've got the first part. What's the second bit? What's the next bit? A plus B plus C is going to be equal to -8. Okay, so it's the first term of the quadratic pattern that is equal to -8. What do we do with our 3a now? Can anybody remember the rule? There we go. There we go. Lovely, lovely. Well done, guys. 100%. Okay, so 3a plus b is going to be equal to 1. First pattern, sorry, first term of our first difference. Okay, since we know what a is, we can go ahead and go and substitute in. And we can work out what b is. And we can see here that we would get 1 minus 9. And that's where we would get our -8 from. Okay, so this is working out nicely because what they're asking us to prove, we're discovering the same thing. Okay, and now we're going to use our last rule, okay, which I think you all know what that is. To get the last value, which is C, we've got to use the rule. A. That's it. Lovely, Fahim. Well done, Valerie. Quite right. A plus B plus C equals -8. And now we can go and sub these values in. So we've got 3 plus -8 plus C would be equal to -8. And of course, if we took our -8 over to the other side, it would cancel this 8 out. So when we take our 3 over to the other side, we're going to end up with -3. Okay, there we go. All right, so we have been able to prove it. So we would then conclude, therefore, Tn equals 3n squared minus 8n minus 3. Okay, so now here this was out of 3 marks. I would think it would be a mark for A, a mark for B, and a mark for working out what C was. All right, accurately. Probably actually, that's not correct. Would probably be on that line over there, and probably on that line over there, and probably on that line over there, because they're not going to give us marks for things that they've told us. Okie dokes. Now, the next question. Between which 2 terms of the pattern will the first difference be 79? Show all working. Well, what does this mean? Between which 2 terms of the pattern will the first difference, beg your pardon, be 79? What are they referring to? What is 79? What do you guys think? Sure, so it's an nth term. I agree with you. It could be an nth term. Of which pattern, Fahim? The quadratic pattern or the first differences? Do we think that 79 is part of our quadratic pattern, or are they telling us that it's part of our first differences? Quite right. Okay, they're telling us that it is part of our first differences. So we can see here they've used the word between which 2 terms of the pattern will the first difference be 79. Okay, so in other words, they're telling us that somewhere down in this pattern over here, when we take one term away from another, we're going to end up with 79 as one of our outputs in our first differences row. So if 79 represents an nth term of the first differences, what formula are they asking us to use? Oh, Diana's got the answer already. That's not the answer I got, Diana, but maybe I made a mistake, but let's just double check. That's it. Specific, perfect. Okay, so it's Tn in Tn equals A plus N minus 1D, 100%. Okay, so that means we are, let me write over here. Okay, we are using Tn equals A plus N minus 1 times D. Buhle, I see you've got your hand up. Do you want to ask a question? You're welcome to unmute and ask. No, Diana, I also make mistakes. Buhle, you're welcome to unmute and talk.
Bush's name does not have the.
Oh, maybe that's because she's using a tab. No, that's Ntokozo that's using a tablet. Buhle, you're welcome to type a question into the chat for us. And either Neliswa or I will help you. I see Ntokozo's having problems as well, Neliswa. I don't know if you can maybe just chat to her about that and see.
Oh yeah, I am.
Okay. Faheen, what did you want to say?
Ma'am, for the constant difference, don't you maybe have to use a second term? Because when you said 7 minus 1 gives you 6, won't that be part of this constant difference? Because the first difference will make sense for this formula. Is it going to work?
It will work. It will work because you see, Faheen, our first differences. So in other words, this row over here is going to always be linear because our pattern is quadratic. Okay, so here is our quadratic pattern in our first row, but our first differences are always going to be linear. So that's why I think it was Spare who said, let's use this formula over here, which is quite right, because that is how we would interpret an nth term question for an arithmetic pattern. So that is 100% correct. Okay, so no problem.
Doubting my conscience to ask the question just to make sure I'm right. I was just doubting myself.
Absolutely, that's why you're here. That's why you're here. So no problem. You ask away. That's why we're here. All right. So we have decided that this 79, all right, has to be a Tn, okay, which it certainly is. So if they say to us between which two terms, what letter are they implying we need to solve for? What do they want from us? Do they want A or N or D? What do you guys think? They want N, quite right. Okay, they want N. Okay, so between which two terms means they want the N from us, which means we need to know what A is. What would A be equal to in this case? A is equal to? Good. A is equal to 1. Okay, remember we're working with our first differences. Okay, so A is equal to 1. That is the first term of our first differences. So we're going to substitute 1 over here. N minus 1, and then we've got to substitute in our D. What's our difference? Our difference is 6. Quite right. Perfect. So now we're going to do that. Okay, so Diana, I got between term 14 and 15, but let's just see, maybe I'm wrong. Okay, we're going to multiply n, so we're going to get 79 is equal to 1 plus, and then we're going to multiply n, so 6n minus 6. So if we leave 6n on this side and we take the 1 and the 6 over to the other side, that means that we're going to end up with, I got 84. I don't know what the rest of you are getting, but I got 84. All right, dividing both sides by 6, n is equal to 14. Okay, so in other words, what we've calculated is that 79 is the difference between term 14, and term 15. Okay, because if we go back and we have a look over here, here's term 1 of our pattern and term 2 of our pattern. Term 1 of the first differences sits between term 1 and term 2 of the quadratic pattern. Similarly, term 2 of your first differences sits between term 2 and term 3 of your quadratic pattern. Okay, so we know that 79 is going to be the first difference between the 14th and the 15th terms. Okay, good stuff, everybody. How are you all feeling? Does it make yes, that's it. That's perfect. Well done. How are we all feeling at this point? Let's just check in with you guys. Are you all happy, making sense? Any questions? Good. Good. Nice. Lovely. It's all making sense. Good to Melo, I'm glad. That's a nice smile, Spare. Thank you. All right, let's go on and have a look at the next question. All right, so now it says to us, the following arithmetic sequence is given. So they go 20, 23, 26, 29, 101. All right. The first thing that they ask us to do is they ask us to calculate the number of terms in the sequence. Okay, they ask us to calculate the number of terms in the pattern. So now we know that we can use a TN formula to do that, and we can use an SN formula to do that, right? But have they given us a series? It's not a series, it's a sequence, isn't it? What does this number 101 here at the end represent? What are they implying that that is? Is it an SN or is it a TN? What do you think? Yeah, it's the last term. It's a TN. Okay, it's a TN because it doesn't have an equals to. All right, if they had said, you know, this plus this plus this equals, then by putting the equals there, they are implying that the number that follows the equals, that would be an SN. But here they are implying that 101 is the last term in the pattern. That's what they're implying. Okay, so this is the nth term or last term. Okay, so if that is the nth or last term, what they want us to do is they want us to work out what the corresponding n is if Tn is 101. So again, what formula are we going to use? Remember, the pattern is arithmetic. So we have to use our Tn formula for arithmetic sequences. Okay, so that is Tn equals A plus n minus 1d. And that's in fact the one that we have just used in the previous question. All right, if they're asking us to calculate the number of terms in the sequence, what letter do they want us to calculate? Remember, 101 is our Tn. What letter do they want from us? Lovely, they want n. Good stuff. Okay, so that means we need to know A and D. The value of A is? Good stuff, everybody. The value of A is 20. Good, very nice. What is the value of D? What is the value of D in this case? Perfect. Good stuff, everyone. Okay. So now again, we're going to remove our brackets. We're going to multiply n. We're going to end up here with 3n minus 3. And if I leave 3n this side and I take the numbers over to the other side, all right, interestingly enough, I get 84. No coincidence there with the previous question. And then if we divide both sides by 3, I ended up with n is 28. Are you guys getting the same answer? That's it. Okay, Therefore, there are 28 terms in the sequence. Okie dokes. Good job, everybody. Okay, now for a thinking question. In 3.2.2, it tells us if the odd numbers are removed from the sequence, calculate the sum of the remaining terms. So they want to remove the odd numbers and they want us to calculate the sum of the remaining terms. How do you think we should? Sure, Faheen, go for it. I see your hand is up.
Ma'am, I didn't get the answer to 28. I got something else.
Okay, what did you get?
I got 39,3.
Oh, okay. All right. So there's no ways that your answer can be a decimal when you're working out n, because n always has to be a natural number. Okay, so that means it has to be 1 or 2 or 3 or 4, etc., etc. Okay. Did you also have 101 equals 20 plus n minus 1 times 3?
Yes, I did, because what I did was I said
Okay.
20 minus 3 and I got 17. So I said 3n minus 17. That's what I said. So that's how I got it.
No, that's fine. So if you've got, oh, but hang on, you've got 3n minus 17. 20 minus 3 is positive 17.
Oh no.
There we
Oh
go.
no.
That's it's just a little mistake. Okay, but that's where your error is. Okay, so
Thank
20
you.
minus
I
3,
didn't
no
notice that.
problem. It's okay. We don't notice these things. Okay, cool. Good. I'm glad we sorted that out. All right, 3.2.2. If the odd numbers are removed from the sequence, calculate the sum of the remaining terms. What do you think we should do here, Matrix? Even if your suggestion is not correct, it doesn't matter. That's why we're all here. Nobody's judging you. What do you think you would do? I mean, if you look at the pattern, I mean, that's the thing with numbers, right? So either they can be odd or they can be even. Yes, Nick, it is an SN question. Yes, quite right. You've got to use the SN formula. It is an SN question. But numbers can either be odd or they can be even, right? They can't be anything else. So if they remove the odd numbers from the sequence, what's left over?
Ma'am,
Go for it, Diana.
if you minus the thingamabobby, then there are 14 terms that are even.
There we go. Now that's also lovely. Okay, you guys are getting the right idea. So
And
I'm hearing.
ma'am, I don't think you read my other one, but
Oh, sorry.
there's an SN formula which has the L, which is the last term, because they also gave us the last term.
Yeah,
I can't remember the
quite
formula.
right. Yeah, no, you're quite right. And that formula
But
is
that
actually not, it's, yes, absolutely. That formula is actually not given to us on our formula sheet. You're quite right. But there is that one that we're allowed to use as well. Quite right. 100%. Okay. Okay, I mean, I suppose we could do it that way, but if we use our traditional SN formula, okay, the n over 2 times 2a plus n minus 1d, let's just think carefully about what needs to go into this. All right, first of all, Diana said, how many terms do we have? All right, so you can see it starts with an even number and it ends with an odd. We know that there are 28 terms. So that means that we have to have 14 even numbers and we have to have 14 odd numbers. So we know, before we get started on this question, let's just put this down, that in 3.2.2, n has to be equal to 14. We also know that we have to use an SN formula. So we know that SN equals n over 2 times 2a plus n minus 1d. Now, what do they want us to calculate? Do they want us to calculate the SN, the n, the a, the d? What is it that they're wanting us to calculate? Which variable are we solving for? Exactly. So SN is what we're solving for. This is the one that we want. So that means that we have to know, we need to know N, which we do. We also need to know A, and we also need to know D. So now the question is, what's A and what is D? Sure. So in the previous question, when there was a combination of even and odd terms, there were 28 terms, Nick. Okay, so the first term was 20, which is an even number. The second term was 23, which is odd. So the pattern goes even, odd, even, odd, even, odd, even, odd, all the way to 28. So because it starts with an even number and ends with an odd number, there have to be the same number of even and odd terms. So 14 odd and 14 even. That formula, you can also use that one. Yeah, it's n over 2. But yeah, Sn equals, it's n over 2a plus l. But yes, you can use that as well, Tumelo. That's not a problem. No, you're not going to sub in 28 because they wanted us to remove the odd numbers, Nick. So if we use 28, then we're using odd and even. So they wanted us to remove the odd numbers. So that's why there would only be 14 numbers left and they would be even numbers. Does that make sense to you? Okay. All right. So the n is, if n is definitely equal to 14. Okay. Where were we? Yeah, so my question is, what is A equal to? A is equal to 20, absolutely, okay, because it's the first number and it's an even number, right? Plus n minus 1, so that's going to be 14 minus 1. And what is our difference? I think someone already said that. Okay, our difference has got to be, remember, between odd and even, the difference is 3. Between even and even, the difference is 6. Okay, so those of you that are saying that the difference is 6, that's correct. Okay, the difference is 3 between odd and even terms. Remember, we are removing the odd numbers. So we're only looking at the even numbers. So there's a difference of 6 there. Okay. Does that make sense to everybody? And then we're going to pop that baby into the calculator and hey presto, we should have an answer. What are you guys getting?
Ma'am?
Yes, and Tibucheng, what did you get? Do you want to ask a question?
Yes, since you said n is 20 because it's an even number. If the first one was an odd number, then we would have to take the next one, which was an even.
Correct. Correct.
Oh, okay.
Absolutely. 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 So, I mean, if they asked us to calculate the sum of the odd numbers in this pattern, then we would have to start at 23 and we would have to end at 101. As it turns out now, we're starting at 20 and we're actually ending at 98. So if we wanted to use that other formula, then our pattern would end at 98. That would actually be our last term. I see somebody else has got a hand up. Who did I miss? Bonolo. Go for it, Bonolo. Pleasure.
Ma'am, why is the difference 6?
Okay, Bonolo, no problem, Bonolo. I understand why this is confusing. Remember, the question says to us that we are taking out the odd numbers.
Yes.
So that means that 23 is not there anymore. And 29 is not there anymore. So our new pattern, Bonolo, starts at 20, and then the next number is going to be 26. You see, and then after that, it would be 32, all the way down to the last term in the pattern, which would be 98. Okay, so what I'm saying now is between even numbers, there is now a difference of 6. Does
Yeah.
that make sense, Bonolo?
Yes, ma'am. Thank you, ma'am.
Lovely, 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 lovely. All right, Nick, are you getting decimals, Nick? I got 826 for this particular question, which I saw somebody else also put into the chat. You got a decimal. Did you put, Nick, did you put in exactly what we said over here? So in other words, the 14 over 2 times 20 plus 14 minus 1 times 6. Interesting. You're getting decimals. Have you not maybe turned, just maybe reset your calculator? Okay, so Sisanda, no problem. Oh, you didn't sub 14. Okay, that's why. All right. So Sisanda, you said you don't understand why it's 14. I'm going to just explain that again. Okay, no stress. So let's just move this down and create some space here. Okay, so Sisanda, the first term in this pattern was an even number, which was 20. The next number was an odd number, which was 23. Then it went back to even again. Then it went back to odd. Okay. And so it went on, and the last number over here was odd. Remember, in question 3.2.1, we worked out that there were 28 terms in this pattern. All right, so the pattern goes even, and then odd, and then even again, and then odd, and then even, and then odd, and then even, and then odd. So here we would have an even number, and then we would have an odd one, which is our very, very last term. So we can see that for every even number we have the same number of odd numbers. All right, so in other words, we can take 28 and divide it by 2. Okay, because either it can be even or it can be odd. Does that make more sense, Sasanda? So we start with an even number, we end with an odd number. So 14 of the numbers have to be even, 14 of them have to be odd if the number of the terms in the pattern adds up to 28. So that's why we know that it is a sum to 14. There are 14 numbers in the series. Okay, and our difference between each of these ends up being 6 rather than 3. Okay, so that was definitely a proper thinking question, wasn't it? All right, how are we all feeling now? There we go, Nick. Perfect. 100%. Yes, somebody else has got a hand up. Go for it.
Ma'am,
Hello.
for that question, 3.2.2. Now, what if you have somehow the same sequence as that, but they ask you for multiple of 6s in that sequence? And how do you get that?
Yeah, that's actually a very good question. So they do often do that, where they will ask you for, calculate the sum of the multiples of 3 or calculate the sum of the multiples of 6 or whatever the case is. So that sort of problem would end up being a difference problem, right? So you know what I'll do is I'll try and find one that I can do with you. But what you would do in a situation like that is that you would calculate the sum of the total series, and then you would subtract the sum of the numbers that say are divisible by 6. Because you could make a pattern with the numbers that are divisible by 6. It would be an arithmetic pattern, wouldn't it? Okay, and then what that would leave you with would be the sum of the numbers that are not divisible by 6. So it would be a difference problem. So by difference, I mean you have to subtract. Okay, and in fact, you know what, we could even do that. We could do a difference problem here to answer this question, because we could say that the sum of the even numbers is going to be this total sum of the numbers minus the sum of the odd numbers. So we could do it that way as well if we wanted to. Okay, so that formula is when you are going from a TN to an SN or vice versa. All right, so so TN equals SN minus SN minus 1. Okay, that is, it actually comes from the old higher grade back in prior to 1998. We don't actually see a lot of questions like this. But how, I don't know if you want me to explain quickly how it works, but it's not very common anymore. It used to be, but it's not very common anymore. But yeah, so simply don't even worry about it. Don't even worry about it. It's not on your formula sheet. It really is a sort of extension question. We really don't see it very often anymore. So yeah, don't stress. You won't see that on your formula sheet. Okay. It is very interesting. It is very interesting. All right, well, if we've got time, maybe we can talk about it a little bit at the end. Yeah, but it's an old formula. That's right, Tumelo. Okay, so that sort of comes from the old higher grade. It's not something that we use. That's true, Nick. Yeah, number patterns can be very, very difficult, certainly. All right, should we have a look at this geometric sequence now and see where we end up? Okay, so essentially it's used when you need to go from an SN to a TN. So the idea behind it is, okay, you don't want us to, okay, we won't talk about it. Okay, it's fine. So we'll talk, maybe we can talk about it a little bit at the end. Let me rather do this geometric sequence, because if it's not really relevant to you guys now, then yeah, it's not. There we go. Quite right, Nick. All right, so now we're talking about geometric sequences. And if we're talking about geometric sequences, we need to start thinking about the geometric TN and the geometric SN, depending on what the question asks. So here our clues are: the first term of the geometric sequence is 1, 2, 1. And the second term of the geometric sequence is 1, 3, 3, 1. What they want us to do is calculate the 12th term of the sequence. So what formula are we using? Are we using an SN or a TN? What formula do they want us to use? Is it an SN or a TN formula? It is a TN formula, quite right. So if you recall, TN equals AR to the N minus 1. So if they have told us that they want us to calculate the 12th term of the sequence, they are telling us that N is equal to 12. So we know we're calculating term 12. So if we want to calculate term 12, it means we need A and we need R. All right, what is the value of A in this case? Quite right. So A is the first term of the pattern. So it's 1, 2, 1. How would we calculate R? Good job, everybody. How do we calculate R? Calculate R by saying, that's okay, Deanna, don't stress. We would divide term 2 by term 1. Okay, in order to get our R. Lovely, everybody. Term 2 divided by term 1. So this gives us 1,331 divided by 1,21. So I don't know about you guys, but I'm getting my R as 11/10. Anybody else get that same answer? If you want to work with it as a decimal, that's also fine. So if you want to work with it as 1,1, that's not a problem. We can do that too. Okay, all right. So now A is equal to 1,21. R is equal to 1,1. N was equal to 12. And then we mustn't forget to. And then you can tell me what you guys get as an answer. Yeah, me too, and because I also got 11/10. There we go, Nick. That's the answer I got too. So 3,45. That's it. Cool, Ntebogang. Lovely. Good, good. Yes, Benolo. 100%. Okay. Calculate first 15 terms of the sequence. All right. Three, 2. Use an SN formula indeed. Okay, they want us to calculate the sum of the first term. So now sum to 15. So sum to n equals A. And then I don't know if you remember this, it's R to the n minus 1 over R minus 1 like that. Okay, that's on your formula sheet. And you must be very careful when you write this formula down because it's so easy to get confused. Here, your n minus 1 is in your exponent. Here, the minus 1 is not in the exponent. Okay, it's R to the n minus 1. Okay. Oh, I see there are a couple of people with hands up. Go for it. Can't see who. You're welcome to unmute.
Yes, ma'am. I wanted to ask, how do you know when it's 1 minus R instead of R minus 1? Because sometimes.
Bonolo, it doesn't matter. It doesn't matter. What you will find is that it's only this one that's actually on the formula sheet. So the 1 minus R to the n over 1 minus R is actually not on the formula sheet. And I don't know what your teacher did at your school, but I don't even teach that to my matrics. I just use this formula because that's the one on the formula sheet. I don't even mention the other one. Okay, but if you used it and you used it correctly, you get exactly the same answer. Okay, so it doesn't matter.
No problem.
No problem. All right, so then I see Orotile, you've also got your hand up. Perfect, Diana. Nick, I think you're confusing it with something else. Yeah, Cassandra, it really doesn't matter. I promise you, it really doesn't matter. You don't have to do that at all. I never, ever teach that other formula. So it's only teach this one, but it really not going to make any difference. Yeah. Okay, and I see you all getting the same answer there. So that looks really good. So it was just Mr. Fandorp. Did you want to ask a question? You're welcome to unmute and ask. You want to see the question again? Okay, and Tebogen. There we go. So we're calculating the sum of the first 15 terms of the pattern. Okay, so we're calculating a sum to 15. All right. So we already know what A is. We know that A is 1, 2, 1. We know what R is. We know that it's 1, 1. We know what N is. They told us that because it was summed to 15 minus 1. And then all of that is going to be over 15 minus 1. And then I quite agree. I shouldn't be writing on the right-hand side here. I should be writing underneath. But anyway, it doesn't matter. I got the same as you. I got 38,44. Okay, no, so there we go. Nick, what you're thinking about here is sum to infinity. Okay, so sum to infinity is A over 1 minus R, and then R has to be a number that is between 1 and -1, but cannot be 1 or -1. Okay, that's what you're thinking about. All right, as far as N is concerned, okay, the restriction on N has to be natural. So when I say the word natural, I mean it has to be a counting number. All right, so when we start counting, we will always start counting at 1. So 1, 2, 3, 4, etc., etc. Okay, so N, if they ask you to calculate that, has to be a natural number or a counting number. When you were doing sum to infinity, the restriction on R has to be greater than -1, but smaller than 1. Okay, Sinasipo, I see you've got a question. Jacques, it said something. Yes, yes, go for it.
We were calculating we gave us the formula, right? So you said A is 12, right? So how can R, how can N?
That's okay, KK.
Sorry?
Sinasipo, I think somebody else was just talking over you. Carry on.
How can N and R be the same? N is 15 and R is 15.
15? No. So N is equal to 15 in this particular case. R was equal to 1, 1. So here I'm gonna highlight it for you in blue. Remember, R is equal to 1, 1. So here where we took term 2 and we divided it by term 1, here's our R.
Yes, ma'am. Ma'am, look at your answer at 3.3.2. You said yes,
I see there. Thank you. Now I see what you're saying. Here, that's where I wrote 15.
Yes, ma'am.
Okay. I'm so sorry. I'm so silly. It's been a long day. I beg your pardon. That was supposed to be 1, 1, wasn't it?
Yes, ma'am.
There we go. Thank you. Thank you. My apologies. Okay. Yeah, I did make a mistake, Joshua. You guys are quite right. Sorry, I wrote 15 here. I wrote N minus 1 instead of R minus 1. Okay. My apologies, guys. Okay. Cool. I'm glad we sorted that one out. All right. So now we've got just a little bit of time left. Let's do this last question. Okay. And Nick, this is what we've been talking about here, because they're talking about for what values of K does the series converge. So that relates exactly to sum to infinity. And we can see here, this is a sum to infinity question because, okay, they've given it to us with sigma notation, but of course the clue here is your infinity symbol up at the top over there. All right, so sum to infinity of K minus 3 over 2 to the N from N equals 1 to infinity. For which values of K does the series converge? All right, so what are we going to do here, Nick? So wait for a series to converge. R has to be greater than -1, but smaller than 1 for a series to converge. So Tumelo, we're actually not evaluating here. What we're doing is we're working out the values of K for which the series converges. So they don't want us to sub in, because look here, we've got two different variables, okay? They want us to solve for K, all right? So even if we did sub the 1 in, we would have all our terms in terms of K, exactly. So R is greater than -1, but smaller than 1. So the question is, what is R equal to? What are they telling us here? What is R equal to? Not for this question, Diana, because they don't want us to evaluate. They're not asking us to calculate a sum to infinity. They're asking us for which values of K does the series converge. So that's why we're not subbing in. Okay, because the question is not asking us to calculate a sum to infinity. It's asking us for which values of K will the series converge. All right, so R is equal to K minus 3/2. So we are going to take this and we are going to substitute it in here. Okay, so next line. So K minus 3/2 has to be greater than -1, but smaller than 1. That's what they are telling us. Okay, so R is equal to K minus 3/2. So now what are we going to do to our inequality? What's the first step? What would you do, Cassandra? You're welcome to unmute and mic.
Ma'am, since we have -1 and then is -1 is smaller than K minus 2/2, can't we say that -3/2 multiplied by -1, which will be 3/2, and then -3/2 multiplied by 1, which will be -3/2?
I would be interested to see what you would be writing on your page. But what I would rather do here, Cassandra, is when we're solving for an equation or an inequality where there is certainly a linear inequality anyway, where there is a denominator, we want to get rid of the denominator. So typically speaking, the first thing that we would want to do is we would want to multiply every single term by 2. So I'm going to multiply this by -1 by 2. I'm going to get -2. I'm going to multiply K by 2. That's going to give me 2K. I'm going to multiply -3/2 by 2. That's going to give me 3. And I'm going to multiply 1 by 2, and that's going to give me 2. So now I've got rid of the denominator. Now, after that, I want to go and add, yeah, that's the idea into causal. Now I want to add 3 everywhere. Okay, so I'm going to add 3 to the end and I'm going to get 1. And I'm going to add 3 in the middle and I'm going to get 2K, and I'm going to add 3 at the end over here and I'm going to get 5. And now I can divide through by 2. So I'm going to get 1/2 over here, K over there, and 5/2 here. Okay, quite right, Tumelo. That's what I'm getting as well. Okay, so for the series to converge, K has to be a number between 1/2 and 5/2. All right, good job, Nick. Well done, Tumelo. Lovely. How are you guys feeling? Is this making sense? Any questions? Go for it, Nick. What's your question? Which one, Palesa?
Hi, ma'am.
Okay. Hi, Nick.
So can I tell you the question because it's algebra?
Okay.
Okay, the question says it is given that k to the power of 1 over x is equal to 3, and k to the power of 1 over y is equal to 4, and k to the power of 1 over w is equal to 12. Prove that w is equal to x times y over x plus y.
Prove that x.
Prove that w is equal to
Yeah.
xy over x plus y.
Did I write that correctly on the screen? So
Yes.
k to the 1 over x equals 3, k to the 1 over y equals 4, and k to the 1 over w equals 12. Prove that w equals xy over x plus y. Okay, so what I'm going to do, Nick, is I will work this out for you with... Did I make a mistake?
Yes, it makes sense. I already did it, but I want to see whether my answer is right.
100%. Okay. Unfortunately, I'm not going to have time to do it now because Nelly and I've got to go and teach another class. But you're going to be here on Thursday, right?
Yes. No, it's fine.
Okay. So then I will do it, and then I promise you I will show you on Thursday. That'll be the first thing that we do.
Okay. Thank you, ma'am.
Okay. No problem. No problem. All right. So yes, guys, as an alternative, I suppose what we could have done here is we could have added 3 over 2 to each side. All right. So if you add, so here is an alternative method. And then Nelly, I must go.
Yes.
I don't know if you want to explain that to them as an alternative method. They can add 3 over 2.
Yeah. Both sides.
To all 3 sides. And yeah, that would be exactly the same thing. I'm so glad into Corso. I enjoyed teaching you guys. Thank you so much, everybody, for being here with us.